Okay, on page 383, practice now 6. You are told to find the coordinates of the stationary point. What's the keyword here again? Stationary point. So, Chao Ting, when you know the word stationary point, what's the first thing that comes to your mind? Okay, the gradient is equal to 0. So now, after finding the coordinates, you are told to determine the nature of this stationary point. Yesterday, you made use of the box method. Alright? Today, we are going to learn the second derivative test. Okay? Today, we're going to learn the second derivative test. Like I said, the box method applies for all questions. The second derivative test is only exclusive for certain questions. Jaka, you need to wear your shirt. Ryan, please wear your pants. Thank you. Now, this is the cubic equation. What is the first thing you do first? After something already told us, we need to make sure the gradient is equal to 0. So, okay, find dydx. Can you tell me what's your first derivative in this case? Okay, you find your first derivative first. After you find your first derivative, because we are looking at the stationary point, like what Chao Ting mentioned, the gradient is equal to 0. Equate this. How do we solve over here? Even quadratic, I don't need to do quadratic. Take note now, class, can you please listen here? When you are told to do a work problem on stationary point, most of the time, 99% you are able to factorize. Don't need to use the quadratic formula one. We are not out to kill you. Then what are you going to do? How to solve, Steven? No, not press calculator. How to simplify? Divide everything by 6. After that, don't press the calculator. What do you need to do? You need to, Steven? You need to factorize it, FA. Of course, you can use your calculator to double check on it. But like what I want to say is, in a typical work problem on stationary point, we won't kill you one. No need to use quadratic formula. You should be able to get nice integer values. Or if not, nice fraction itself. So in this case, x is equal to 2 or x is equal to -1. Am I right? After that, what do we do? Find y. Do we need to show the whole chunk of working? No need. Straight away plug in the value of x equal to inside the original equation. So Melissa, when you plug 2 inside here, what answer do you get for y? Can you press the calculator for me? Likewise, Hui Xuan, you press when x is equal to -1 inside the original one for me. This is negative 20, 40. Hui Xuan, 13, positive. Okay, remember, they ask for the coordinates of the stationary point. What I want you to do, like I said yesterday, please write out the keyword stationary points. Alright? Write out the coordinates. This was what we did yesterday. Am I right to say that? After you find the stationary point, the question will always ask you to determine the nature. Yesterday, we made use of the box method. Alright? Today, I'm going to use the derivative, the second derivative test. So don't copy first. You see how I make use of the second derivative test. Make a good guess. From this word itself, second derivative, what do you think you need to do? d square y over dx squared, because you need to differentiate the first derivative for the second term. Alright? So, d square y over dx squared. So very quickly, I need to differentiate this. No brainer lah, huh? Very straightforward, right? Okay, now, there are some other things you need to take note, alright? This one you need to remember. There can only be two outcomes. Alright? For the second derivative test, there can only be two outcomes. What are the two outcomes? If your second derivative is greater than 0, this will imply this must be a minimum point. I say again, if the second derivative, the end result is positive, this will be a minimum point. So the converse is true as well. If the second derivative is less than 0, what do you think will be the conclusion? Maximum point, thank you. But I need to alert you, if the second derivative test is equal to 0, this will be inconclusive. You cannot conclude anything. Then what does this mean? Not say no solution, It just means that you cannot make use of the second derivative test. You need to go back to the box method. Okay? This means since it's inconclusive, you need to make use of the box method. And most likely, when you make use of the box method, this will give you a point of inflection. But I want to stress on this again. You cannot tell me the second derivative test is equal to 0 and conclude it's a point of inflection. Cannot. Okay? You can only tell yourself, oh, Mr. Liu mentioned we can only conclude when the second derivative test is positive and negative. It will mean minimum and maximum point respectively. But the moment it's equal to 0, I need to go back to the first method again. And that is the reason why I don't want to teach this method first. And there is another reason. What do you think will be another reason why sometimes we may not want to use the second derivative test? Anyone? Anyone? Not really. When, of course now these are all the easy examples. As we move on, there will be some examples. The first derivative, need to use quotient rule and product rule, already quite difficult. Then you still want to use the second derivative, use the quotient rule and the product rule one more time, you are killing yourself. So the box method may be a better method in that case. But it is very easy to differentiate to find the second derivative. I will encourage you to use the second derivative test. So when do we use the second derivative test? When it's easy differentiation. Okay? When the differentiation is very easy. Is it very easy to differentiate in this case? Super easy. 2 seconds can finish already. Now, let us test what result do we have. Okay? See how I do the working. At this point, okay, unlike the box method, we need to make use of the result of the second derivative test. D square y dx squared. Do I plug in 2 or negative 14? Inside here. Y2. It's just the x coordinate. I don't need the y. But this is the coordinates of the point, so I need to write this down. Okay? So when I plug in 2 inside here, very easy one. 2 times 12, how much? 24 minus 6? 18. You don't need to write 18. If you want to write 18, you may. Is 18 positive or negative? Positive. So even if you don't want to write 18, you just have to show me the second derivative is greater than 0. It's good enough already. Do you remember yesterday when you first do the box method? I told you don't need to write down the value. You just need to show me whether is it positive or negative. So same thing, you just have to tell me this is positive. So if the second derivative is positive, what do we conclude? It will be a minimum point. Then you write down 2, negative 14 is a minimum point. Okay, we can write shorthand. You need not really actually write everything out in full. This is one way of presenting it. I'm going to show you another way of presenting. Instead of writing at this point, I can also write when x is equal to negative 1 for the second point. Because I don't need to substitute the whole thing inside, am I right? The only thing that's required for the second derivative is the value of x. So I know specifically the value of x is negative 1. So now I substitute negative 1 inside here. I have a negative 12 minus 6, which is negative 18. Do I need to write down negative 18? No need. So d square y dx square is negative 18, means this is less than 0. What will be your conclusion over here? It will be a maximum point, but you need to write out the full coordinates. Okay? So this part, this whole thing, all the way until here, usually is 5 to 6 marks. Okay, usually is 5 to 6 marks. Then, notice they ask us to sketch the curve again. Can you do the sketch for me now? Thank you. I'm going to give you 2 minutes. You try the sketch. You can copy later, but you try the sketch first. Okay, I'm not going to do the sketch this time round. You try the sketch yourself.